Hello everybody, this is Saif Habashi. I know it seems obvious and trivial, but we don't do trivial stuff here. We're looking at this integral from a different perspective, and I like looking at the things that I already know from different perspectives and get the same result from a really different view of the thing. I know most of the viewers of this video see this integral as this integral, just the antiderivative of sine is minus cosine, substituting with phi is negative cosine phi, minus substituting with 0, so it's minus 1. So 1 minus cosine phi is the result of this integral, I understand. But looking at it from a different perspective, wherever sine or cosine exists, there is a unit circle. You see how perfect this circle is? I like it. Okay. Let's assume this is a straight line, okay? And this is a unit circle, and we are examining this unit circle, okay? So there is some angle here, phi, or theta. This angle is theta. And there is a tangent at this point. Assume it's a tangent, right? So if we make a vertical line like this, if this is theta, then this angle is also theta, because this is a right triangle and this is a right angle, so this is 90 minus theta and this is 90, so this is theta, okay? Okay, perfect. So if we examine at this point a very, very small length, very, very small arc, I mean, like this, and this is d theta. All right, so this arc, looking at it like this is the d theta. We can look at it as there is a triangle here, and this triangle, this part is tangent to the circle, so this angle is theta, the same way this angle is theta, because this is tangent, so this angle is theta, the same way here, okay? Which means that this length is d theta sine of phi, or to write it in a mathematician way, sine theta d theta, and this is cosine theta d theta, right? So, to integrate sine theta, we need to go from 0 to phi. We need to go from theta equal to 0 until theta equal to phi, whatever this phi equals, and sum up all the horizontal segments. So there is a very, very small segment arc here, and this arc has a very, very small projection here, which is actually here. And this arc has one here, and this arc has one here, and so on. These infinitesimal parts add up to this integral. So this is a unit circle, so this radius is 1. So adding up these parts till theta equals pi over 2 gives 1, which is actually right. If you substitute phi equal to pi over 2, this integral evaluates to 1, and does not stop here. What is the maximum value of this integral? We are integrating sine of theta, and we said that integrating sine of theta is equivalent to adding up these segments as theta increases from 0 to phi, whatever this phi is. So the maximum value is adding up the whole thing, which is from 0 to pi, and this results in 2. And this is right. Integrating sine of theta from 0 to pi of sine of theta is equal to 2, because the sine curve is like this, and this is pi, and this is 2 pi, and the maximum area of this integral would be getting this whole area. And this whole area, if you calculate it, is 2. This is a cool way of viewing this integral, and I like it. And it does not stop here. When you go until pi, you get the full length of the diameter, and when we increase the angle more than pi, we again get back to 0 if we rotate to 2 pi, and so on. This is a cool view of this integral, and it's the same way with the cosine. The only difference is that instead of integrating this horizontal part, you are integrating this vertical part, right? And the maximum value is 2, and so on. So integrating cosine theta from 0 to pi over 2, look at this circle, from 0 to pi over 2. Well, I'm integrating cosine, so I'm looking at the vertical part, so it's 1. What about integrating from 0 to pi, integrating cosine theta from 0 to pi? So from 0 to pi, so you increase until here, pi over 2, and decrease until here, 0. So the integral from 0 to pi of cosine theta d theta is equal to 0. I'm not sure. I'll see now with you. Drawing the cosine function like this. I know this is pi over 2 and this is pi, and yes, this area is equal to this area, so they cancel out. So it's working. And I like this view, so I decided to make a video on it and share it with you. Don't forget to subscribe, like, and so on, and share this video with somebody who would be interested in seeing this. Okay, goodbye.